The purpose of this short video is to give project participants a quick overview and understanding of the BIM objectives for the Limerick CERC project. For those who are new to BIM, basically the process involves assembling a virtual 3D building in software from objects or components that represent their real-life counterparts. These objects act as a primary placeholder for vital information about the building components. This model can be explored by all participants and stakeholders to improve the communication and understanding of the project, and to make sure everything is going to work and fit together before it's fabricated and assembled on site. This ensures a much more efficient and effective design coordination process. These models can be analysed with software to test structural performance, energy performance, quantity takeoff, clash detection, and program sequencing, giving the team the ability to optimise solutions, reduce uncertainty and risk. Multiple traditional drawings and schedule documents can be automatically derived or output from these models, but the real usefulness of BIM as an approach is that all the information is captured in one place, and if a change is required, managed in one place so that all documents can be kept coordinated and up to date, bringing about enormous efficiencies in creating, managing and exchanging information, and avoiding the duplication of effort associated with the traditional exchange of paper information. BIM should not be seen as something extra added to the traditional design process, but rather as an alternative methodology, a far better, more efficient and more sophisticated way to produce, manage and exchange project information. The reason the client and design team are asking for BIM is that they want to improve communication, understanding and the flow of information on the project. They want to try and identify any issues early on in the virtual model and resolve these before carrying out the work on site. These could be design coordination issues or clashes, buildability or sequence issues, logistics and health and safety issues. The ultimate aim is to reduce the risk for all parties on the project and avoid unnecessary cost, overruns or delays. The project will be carried out to Level 2 BIM. This basically means that each discipline or participant who produces information for the project is doing so using a BIM methodology in a separate model from which their own documents are derived in order to maintain clear lines of responsibility. But these models can be brought together or federated for 3D coordination review. The federated BIM provides opportunity to extend the analysis of the model for project planning or sequencing 4D, cost estimating and control 5D, structural and energy performance 6D, and capturing important facilities management asset information 7D. The project team are encouraged to make as much use of BIM as they have the capability to do, but as a minimum the client and design team are looking for 4D sequencing, programming information and 7D incorporation of all asset information required for facilities management. Unfortunately, the benefits of BIM process will not be realised unless there is a commitment from all participants to contribute to the process, and for that there needs to be a clearly defined standard and managed strategy. That requires every participant to adhere to when making their contribution to the project. The process set out is in accordance with PAS 1192 Part 2, 2013, Specification for Information Management for the Capital Delivery Phase of Construction Projects using Building Information Modelling, or BIM. It is recommended that all participants read and understand this standard. According to this process, an employer's information document has been provided which sets out the client's requirements for BIM. Each participant must provide a pre-contract BIM execution plan to demonstrate how they will deliver on their requirements set out in the EIR. Where BIM capability or previous BIM experience cannot be demonstrated, participants must include a plan as to how they will acquire the capability or resources to deliver BIM for their element of the work. An appointed project information manager will coordinate the efforts and contributions of all parties, as set out in the scope. The specification requires all designers, contractors and subcontractors involved in the project to submit at key stages the asset information required by facilities management for post-construction operations in an agreed, structured digital format. As a minimum standard, COBE, Construction Operations Information Exchange format, has been specified in the UK using Uniclass 2 classification. This will ensure that the data is well ordered and ready to be imported into the operations systems without requiring the facilities managers to retype the information. This is set out in the specification for the digital safety file that is cross-referenced to the BIM data. BIM specialist consultants, ArcDocs, have assisted the client and design team to organise and structure the project information during design stage. ArcDocs are Ireland's leaders in BIM and have been supporting project teams for the last 5 years on over 50 projects. At tender stage, the contractors will be given a read-only version of the federated design intent BIM from which the contract drawings have been derived, which the contractors can explore and interrogate, as will be demonstrated later in this video. The reason the full editable version has not been provided at tender stage is to protect the intellectual property of the design, but the preferred or appointed contractor will be given the full version to use, as they will be required to develop a construction and fabrication model during the construction process. What the contractor and subcontractor are required to do is set out in detail in the BIM protocol the specification, the Employer's Information Requirements or EIR, the BIM execution plan, the BEP. But in short, rather than producing traditional submittal, shop and fabrication information in a 2D process, we are asking everyone to produce their information using a 3D BIM methodology and to bring these models together for review and coordination with the other elements before executing the work on site, so that issues can be resolved as early as possible and risk and unnecessary costs can be avoided. We are also asking that the asset information be incorporated into these models as they are being developed, rather than leaving this to the handover period. Those parties involved in the project will obviously need to have the hardware, software, training and support to deliver BIM, and should take this into account when tendering. But at tender stage, we don't expect anyone to have to invest in any additional software in order to be able to use the read-only versions of the BIM which are being provided. Design Review is a free software application from Autodesk which allows users to open and review 3D models saved in DWFX format, as well as 2D drawing sheets saved in DWFX, PDF, DWG or JPEG format. The application can be downloaded from the Autodesk website. This video demonstration will give you some idea of how you can use Design Review for this project. This free program has some limitations for handling large file sizes, so for the 3D views we've exported these both floor by floor and by each discipline, and the drawing sheets have been exported individually. And you can use these different views of the model depending on what element you're reviewing at any particular time. Design Review is a simple tool to learn and use, but an extremely powerful and useful tool in practice. Firstly, we'll look at the 3D model. As this is a level 2 model, it consists of the architectural, structural and site models combined into one federated model. You can isolate or turn on or off individual models, or even isolate individual parts of each model to help you better understand and communicate with your team and subcontractors. Here we've isolated the windows, and you can use the model tree structure to isolate individual items such as this particular window type. Elements within the model retain their properties when exported from Revit to Design Review, and you can read the properties of an object in the Objects Property palette. In this example of the window, we can see that its size, location, and other data is brought through from the Revit model. You can quickly create plan or vertical sections through the 3D model, which can be saved or renamed to easily go back to at any time. You can use a snapshot tool to save 2D views of the model, which can be renamed as required. You can then use the markup and measure tools to add comments or sketches to the views. Markups can be added in different colors, which will be allocated to different members of the team to quickly identify who has added a particular markup. Markups also automatically retain the identity of the person who created them and can be given a status for review, question, or even marked done. Additional information beyond what will appear in the markups label can be added also. The snapshot tool can be used to capture relevant information from other documents also, and add them to the Design Review file, and then comments can be added to these using the same markup tools. You can also add other files such as JPEGs, PDFs and CAD files by dragging and dropping them to the Views palette. In the Services model, individual services or systems can be isolated, queried and communicated among the project team to give a much clearer understanding of the task required. The dimensioning tools include point location, in this example used to identify coordinates for the concrete foundations. The markup can be saved by exporting these to an Excel spreadsheet, where they could be sorted and extracted for use in other software. Drawing list or thumbnail views allow you to select from a set of 2D sheets. Elevation, section or callout tags act like hyperlinks to allow easy navigation between sheets. The 2D sheet views from Revit also retain the properties or data about an object, and selecting an object in a 2D view will also allow you to display the properties about that object. The markup tools can be used in 2D views to sketch using a selection of lines, shapes or sketch tools, and to add notes or comments. 2D views from Revit are accurate in terms of scale, and Design Review measure tools can be used to quickly measure lengths and areas, angles, and again the snapshot tool can be used to focus on or communicate information about a particular area if required. The Design Review file can also be shared and viewed online on the free Autodesk 360 service. You can create an account with Autodesk 360, upload the files and share the files with the team by inviting team members to join the folder. In the online version, you can also see all the properties about objects and can add comments and communicate with the team. The 360 dashboard provides access to project personnel, a project diary, and a wiki page for sharing information across the team. Once the file has been shared online, you can also access this on mobile devices through the Autodesk 360 app to communicate, view, markup, and comment in the field. This can provide access to all the model, drawings and other project documentation wherever you are, cutting down on paper and ensuring that you always have access to the latest version of the documents. Remember, Design Review and Autodesk 360 tools we have shown here are completely free, and we would encourage everyone to use these to improve and speed up communication on the project. We are also sharing a Navisworks NWD file, and although this can be viewed in a free version of the Navisworks software, Navisworks Freedom, we recommend the full version Navisworks Manage to get the most benefit from this. In addition to most of the uses possible in Design Review, Navisworks Manage provides the additional ability to use clash detection tools, to add the timeline to the project and simulate the construction sequence, and quantification tools to measure and take off elements in the model. Again, in 3D views, you can isolate or hide elements or entire models. We've saved a number of views which will be available to you: views of the individual models, views of each floor, and views in each room. Once you're in a room, you can easily use the walk tool to navigate and explore the spaces. You can highlight objects in any of the model views to query their properties. You can save viewpoints and use the markup tool to sketch, add red lines, and measure elements, and convert measurements to red line markups. And you can add comments to markups and assign status to these. You can easily find comments and tags and track who created these and view their current status. You can navigate between 2D and 3D views, and in 2D you have some additional measure tools for lengths and areas, and also the markup and commenting tools. These are great tools for communicating and tracking communication across the project team. The Clash Detective tool allows you to set rules to find clashes between models or model elements, and allow the software to find and highlight the clashes. You can group elements into sets, which can be used to create rules for clash detection between the sets of elements or assigned to a timeline or task. You can highlight and group associated clashes and assign these to individuals for resolution. The switchback tool allows the model authors to automatically locate the issue in the original models for editing. Clash results can be saved with the model for sharing, or a clash report exported and distributed separately. With the timeline tools, you can create tasks directly in Navisworks, or you can link in an external MS Project, Primavera, Asta, or even a CSV program. Model objects or groups of objects can be linked to the tasks, and once this is done, you can simulate the construction sequence. Simulation can be created automatically from the sets, in this example for a very simple simulation by floor. Contractors can add additional items to the model, such as hoarding, site huts, craneage, scaffolding, and other elements required to construct the building, to include in the simulation. Elements can be animated and even added to the timeline and included to allow for time-based clash detection. Navisworks also includes quantification tools that allow you to create catalog recipes for taking off elements in the model, either 3D model takeoff or 2D takeoff from drawing sheets. 3D takeoff allows elements to be highlighted in the model and attached to items in the workbook. Items which have been taken off can be isolated or hidden in any view. You continue to highlight and take off the model elements, and should the model be updated at any stage, the Change Analysis tool will identify and highlight the differences. The takeoff can be exported to Excel if required, and possibly linked to other quantification and bill creating tools. As in 3D, in any 2D sheet view, it is possible to isolate or highlight items already measured. Tools such as the Area Takeoff tool will allow takeoff of finishes where these have not been specifically modelled, and these areas will be added to the workbook. Also, individual items can be taken off by tagging these in the sheet view. As we said earlier, the ultimate aim of implementing BIM on this project is to reduce the risk for all parties on the project and to avoid unnecessary cost, overruns or delays.